All right, everyone. Today we are going to be talking about assessing normality. The shape of a histogram is what we used previously to kind of determine, is my data approximately normal? Because again, we can't use the normal calculator, or at least not, and expect the results to tell us anything accurate unless the data itself is normally distributed. So when we have a small sample of observations, the shape of the histogram is not always accurate. And so for this reason, we have to have a way to assess the normality of our random variable x when we have smaller samples. So couple definitions. First, the normal score. So a normal score is something we're going to be looking at. And let me get my pen color here. It is the expected z-score of the data value, assuming that the distribution is normal. What we are going to be looking at as well is normal probability plots. And this is a graph that plots the observed values versus the normal scores. So then that tells us, okay, here are the observed values. If the distribution is normal, these are what the normal scores would look like. And how do those two things compare? So I've got the steps that we're going to use in order to assess normality. It is both using a table and StatCrunch. So it's table 6, which you can always find all of the tables in your Canvas. If you go to the table of contents, right before the answer sections are the tables, but I did also copy it onto the back of your guided notes as well. So the first thing we're going to do is use table 6 to find the critical value. Then in StatCrunch, we're going to go to graph and we're going to select what's called a QQ plot. I don't know why it's called QQ, but that's what's going to help us assess normality. So we're going to select our variable. We're going to check the boxes to add the correlation statistic and to have the normal quantiles on the y-axis. And then we're going to click compute. This is going to give us the value of the correlation coefficient. So we've already talked about correlation coefficients when we talked about determining whether linear models were appropriate or not. So that's our R. Remember, R is the variable we use to represent correlation coefficient. If the R that we receive from StatCrunch here is greater than the critical value, then we can say that the distribution is approximately normal. So we're going to do a couple examples here just to make sure you know what you're doing. So this one says use a normal probability plot to assess whether the sample data could have come from a population that is normally distributed. So the situation is a random sample of 20 undergraduate students receiving student loans. So we obtained the sample. The amount of their loans for the 2018-2019 school year was recorded. So you can see here that I've got 20 different values for the 20 undergraduate students. And so that tells me that N is 20. And so now I'm going to use the tables. So when I look at the table, and I'm using the one that's in the book, of course, you need to find the sample size. So sample size N, scroll down, find N equals 20, and the critical value that goes with that is 0.951. So when I go back here, I would say that critical value equals 0.951. You do need to record all of this information. This is your work. So next is when I'm going to go into StatCrunch. Now, obviously, you have to have the data uploaded. I have updated all the links in Canvas, so you should, for your practice problems in the homework, be able to obtain all of the data that you need for that. So let me find, nope, it's this one. So we can, oh, just kidding. It went away. So let me find that. Okay, so here is the student loan data. And as you can see, I have 20 values in there. So all the values that were in the table that they gave me. And so now I'm going to go to graph and I'm going to find QQ plot. Here it is. So select that. Maybe, there we go. So once I do that, I select my variable, which is student loans. Then I need to click to add correlation statistic and to have normal quantiles on the y-axis. You can choose, all of these things if you want with the different values. You can make those what you want. So here it labels student loan and normal quantile, and it gives me up at the top the correlation statistic. So we're looking here, obviously on the red line is kind of where our normality would be. And you can see that like the end values are pretty close to those normal values, but over here, not so much. Definitely this one, not close. But you can see it's not really following that pattern. Again, that's what our eyeballs tell us. We don't use our eyeballs. We use actual data to make the decision, but our eyeballs kind of say, it's not looking like it's holding very close to that normal value, but it's the R that I'm going to use to make that decision. So I write down that R is 0.88, and now I compare. R 0.88 is not greater than 0.951, which means that this data is not approximately normal. So again, that tells us that the things that we've learned from normal distributions in the previous chapter 7 sections do not apply to this data because it's not normal, so we can't use a normal calculator and expect to get accurate results. All right, example 2, a random sample of college students aged 18 to 24 years was obtained, and the number of hours of television watched in a typical week was recorded. Draw a normal probability plot to determine if the data could have come from a normal distribution. Now, again, you're welcome to draw what you see on StatCrunch out on a paper, but I would strongly suggest that you use screenshots and put them into a Google Doc for your practice problems. It would take a lot less time. So I want a normal probability plot, and we're going to do the same thing that I just did in example 1 to decide if it could have come from a normal population or not. So I'm going to go back over to StatCrunch here, and I've got my here's the hours of TV for my various college students, and you can look at the table in the notes, or you can look here. We can see that N is 25. That's my last data value. So I'm going to go to graph, maybe it'll let me click on it. There we go. Graph QQ plot. Hours of TV, add correlation statistic, normal quantiles on the y-axis, and I will click compute, drag it so you can see it. We can see that this time it's definitely looking like the points are closer to that value. And again, we don't make decisions based on just what our eyeballs tell us. Correlation coefficient is 0.992 here. So we need to go back and we need to compare that to what I would see from my table. So N equals 25. The critical value is 0.959. So I have N equals 25. Critical value equals 0.959. And the R that I got from StatCrunch was 0.992. So in this case, 0.992, my R, is greater than my critical value, 0.959. So yes, in this case, it could have come from a normal distribution. So the next thing I want to do is determine the mean and standard deviation of the sample data. So we've been used to, in the past couple sections, them giving us the mean and standard deviation. When we have the data, we typically have to find that ourselves. So I'll go back over here and go to Stat and go to Summary Stats and Columns, Hours of TV. I want mean and I want standard deviation. I always forget how to select multiples at the same time, but one of these days I'll remember what the value is. Is it option? Oh well, I guess what I'm going to do is I'm just going to select all three of those. So I don't need the variance this time, but I'm just taking it along for the ride. In this case, clicking compute. And here is my mean. Here is my standard deviation. So go back to where I can record that. Our data in this case was rounded to the tenths place. We can see that on our data table. So that means my mean and my standard deviation should be rounded to the hundredths place. So 20 point, I think it would just be 90 because I think it was a 4 after that. Let me go back. Yes. And then my standard deviation to 2 decimal places would be 10.52. So standard deviation, 10.52. Using the sample mean and sample standard deviation from Part B as estimates for the population mean and standard deviation, respectively, draw a graph of the normal model for the distribution of weekly hours of television watched. So we have been used to drawing a normal curve. That is what we are going to do here. So don't have room for a very high peak. Random variable x, in this case my peak, my mean, is going to be 20.9. And then just like we have in the previous two sections, I'm going to label 1, 2, and 3 standard deviations, both above and below the mean. So I'm going to continually add the 10.52 on the right side, subtract it on the left side. So if I do that, 20.9 plus 10.52 gives me 31.42. Then add 10.52 again. That gives me 41.94. And then one more time, 10.52 gives me 52.46. On the subtracting side, 20.9 minus 10.52 gives me 10.38. Then I've got negative 0.14. And then I've got negative 10.66. Now, we know that negative values don't really make sense in real life, but that's why we're saying that this is approximately normal. And so obviously the part that we're off is on the bottom part, because we know we can't watch a negative number of hours of TV. Oh, I didn't realize I had this part on the actual notes themselves. I guess I could have saved myself from going to the online text there. So using the model from Part C, find the probability that a randomly selected 18 to 24-year-old college student watches between 20 and 35 hours of TV each week. And the easiest way, of course, to do this is in StatCrunch. As long as it doesn't tell you that you need to use table 5, then that's how I would recommend that you do it. So in StatCrunch, we're going to use the normal calculator. We want to use the probability of our random variable x being between 20 and 35. The way that this looks, because again, we should always draw a picture. 20 is a little bit below the mean, barely, almost right on top of the mean. And then 35 is a little more than 1 standard deviation above that. So this is the area we're looking for between 20 and 35. So go into StatCrunch and stat calculators. And where is my normal calculator? There it is. For some reason, it does not want to let me choose it. Come on, buddy. There we go. All right, so on our normal calculator, just like we've learned before, in this case, we have a between. So I pressed on between so that I could get these values here. I do need to type in my mean and standard deviation. So 20.90 and a standard deviation of 10.52. And the probability of lying between 20 and 35, and then click compute for us to get the answer. So in this case, it is telling me 0.4440 is how we would round that one. So equals 0.4440. And that would be our probability. Then our last one, determine the proportion of 18 to 24-year-old college students who watch more than 40 hours of TV per week. Remember, these are just the 2 different interpretations of what these values. Here it asked us for an individual, randomly selected. Here it's saying determine the proportion. So in this case, draw my same, sorry, that is a rough looking normal curve. But here is my mean, and my first standard deviation is 31. My second standard deviation is 41. So we're looking a little before that and to the right. So we want to know of that being greater than or equal to 40. More than really doesn't mean equal, but again, there is no difference between greater than and greater than or equal to in the normal calculator because our probabilities are associated with intervals and not with individual values. So click on standard again because we do not have a between, so greater than or equal to, in this case 40, and press compute, and we get 0.0347. So 0.0347 is my probability. And we're finished. You don't have very many practice problems to work on. Most of them are data-based. There's a couple definitions. So again, make sure you use the links that I've provided for you in Canvas to upload the data. Make sure that you show all your work and draw your curves.